Okay, we are starting a new chapter today. We're in chapter 5. We're going to be working with some different types of functions that maybe you haven't seen before, but kind of today we'll just spend some time reviewing. So these are the notes that you need to copy down. So I'm not going to go real slow here. I'm just going to read through these real quick, and then you can pause the video and write down everything that I've written down. So you guys should know that a function is a type of relation where every input x goes to exactly one output y. Domain is your inputs, which are typically x, although not always, especially in story problem and real world situations. Range is possible outputs, typically are y. And then our function notation, this is something that confuses people, but after the last chapter, when we use substitution, that's kind of what this is. A method of writing a variable as a function of other variables. The variable y becomes a function of x, so instead of writing y equals 2x plus 3, function notation is just simply written as f of x equals 2x plus 3. So if I took this a little further, real quick, so if you wanted to find when x equals, we'll say 4, you would do f of 4 equals 2 times 4 plus 3. So then that could give us an answer of 11. Okay, and you would also see that possibly written as f of 4 equals 11. Okay, and last for our written definitions, some key characteristics of a linear function. They are written in slope-intercept form, y equals mx plus b, or point-slope form, which remember from earlier is y minus y1 equals m times quantity x minus x1. We can do rise over run. So I wrote these out by hand, but if you guys want to write them as the following, if you're doing this by hand, remember we do rise over run. We can also do our change in y over our change in x. And then we can also do y2 minus y1 over x2 minus x1. Okay, and those are all different ways to write your slope. So really, if you just wanted to write that for number 2, you could. And we also know that it's a straight line. So at this time, you need to probably pause the video because I probably haven't gotten this all written down yet. Get it all written down and then start up again. So when we're going to continue to review here, we're going to sketch some graphs today and make sure that they are linear. So this first one is pretty basic. It's x minus 3. So notice how it's written in function notation. That's just another way that we would have y written. Y and f and x are interchangeable. So you could just use your brain here and subtract 3 from every number. So if I'm at negative 2 and I subtract 3, I'm at negative 5. If I'm at negative 1 and I subtract 3, I'm at negative 4. You'll notice because these numbers are going consecutive, our pattern is going to be the same thing. And 1 minus 3 is negative 2. And 2 minus 3 is negative 1. The other way you could do this is go to Desmos real quick. And I'm just going to show you a cool little trick. That it helps us, but not completely, because I can type in x minus 3. And then if you click the setting button, it does give us a table. It defaults it to negative 2, negative 1, 0, 1, and 2, which is great because that's the one we have over here. And you'll notice that we did do it correctly. You can also change it though. So if you wanted to do like every other number, I always like to stretch things out. So I do like -4, -2, 0, 2, 4. I like to do, that if I was graphing. You don't have to, and it also depends on what it's asking for. So in this case, it just did ask for -2, -1, 0, 1, and 2. And then our other one, 4 minus 2x. So I could come back over here to Desmos, x out of this, go 4 minus 2x. You'll notice my line is going down because it's a negative slope. We could also write that as -2x plus 4. Change it to a table. Notice it goes back to that original table that you can edit, and it just counts down by 2's. 8, 6, 4, 2, and 0. So I can come back over here and do 8, 6, 4, 2, 0. So for graphing these, it says sketch a line. Probably the easiest thing to do would be to go -2, -5. And probably do 3 points, and 0, -3. I don't have to do them all. And then 2, -1. And since it says sketch, I'm not going to use a straight edge. I'm just going to make sure I try to go through those 3 points. There's one. Come over here, 4 minus 2x. So I'm going to be at -2. 8 is actually off the screen, but it would be right there approximately. So maybe I'll just do this one instead. And you get the idea. Okay, last thing for the day. It says identify the pattern and write the linear function for the data in each table. So this is where you would need to check rise over run. Okay, here's my slope, because remember, slope is when, not slope, y-intercept. My y-intercept is when x equals 0. So my y-intercept is -1. So that is my b. And over here, my b is -1. So to figure this out, it says write a linear function. So we only need to do this one time. So you could pick any numbers. My y's are going up by 5, positive. My x's are going up by 1 in a positive direction. So for this one here, I have a graph. The simplest thing is to use y equals mx plus b. So y equals 5x. And then we come back here, -1. Over on this one here, you can really pick any numbers you want. So maybe I pick the whole numbers because it's easier to work with. So I went from -2, or +2, sorry. Went from +2 to -1. So we're going in a negative direction. We move 3 spots. And over here, though, I went in a positive direction. Because I went from -2, and I'm, of course, getting bigger. So that gives me my slope of -3 over 2. -3 halves x. And then I got my -1. So I had already pointed out when x equals 0, my b is -1. A great way to check these, I just paused the video here just to make it quicker. You could hop back over to Desmos on your tab, on your Chromebook or on your phone, and plug these in so you can see here what I did. I plugged in my 2 answers, especially if this was a quiz. and I told you using a calculator is fair game. I plugged in both graphs. I changed the tables to match what I had over here, and I just confirmed that my y equals mx plus b was the same, and it was. So your assignment is 7 through 19. But you need to upload all 3 pages. 1 to 19 with our notes. Okay, and I'm just going to come down here and point out some of these are non-linear. So this right here is the absolute value. So I want you to take a guess on these. And the best way to do this one would be to go to Desmos and just quickly, you're going to want to take a look at this. The best way to do this is to bring up the, once you start typing, you can see there's a little keyboard down here. So you can do X. So if I was doing this one here, and do X, and then the squared button's there, and then I'm subtracting 3. I think is what it was. Nope, 2. But you get the idea. And then I can also do, here's the absolute value sign. So I can do X, and then I need to arrow out of that. So I hit the absolute value again, and it ends it. And then I'd subtract whatever they told us to, or in this case, add. You add 1. Okay, and then you can make tables, and that'll give you what you need to copy down and make your graph. Now on the last page, it asks you whether or not it's linear. So you would want to go through and check your rise over run on multiple ones. So this one, I got 6 over 1 here, 6 over 1 here. You know, it's going to be the same every time. But over here, you'll notice that I go up 1 here. I go, sorry, down 1. And up 1 over here. But then when I'm over here, I go up 1 and up 1. So you'll notice that this is not the same as this. So this is non-linear. And actually what that is, that's the absolute value function that you're graphing on the previous page. But this one's linear, so you could write the function that goes with it. So that's all for Monday. Quite a few problems, but they should go pretty quick, especially using Desmos. So have a good day.